Before we get into 7.2, it's going to be really important that your calculator is in degree mode because we will be looking at angles in measure of degrees. So I have some pictures here between the two kinds of calculators of how to do that. So I'll start with the TIs. The first thing, if I'm just looking at the screen, I need you to hit the mode button, which is right here. And it's going to take you to this menu. What you're looking for is that the word degree is highlighted, which is about the third row down. If it's not, you need to arrow down to that third row, arrow over to degree, and then hit enter. If you have a Casio calculator, what you're going to do is you are going to hit shift and then the menu button, which leads you to setup. And your calculator down here in this row where it says angle, it needs to say deg for a degree. Most of you probably have it starting as rad for radians. And so you need to arrow down to angle. And then if you notice, degree is right here. So I'm going to hit F1. Once you've done this, the way that you can test it is you want to hit here we're going to be looking at all of our sine, cosine, tangent is right here for the TIs, and then Casio, it's right here. So I want everyone to just test this real quick and hit sine of 30 and hit enter. And if it is in degree mode, it will come up with half. And if it didn't come up with half, then you need to go back and put your calculator in degree mode. So what this means, we're going to use that fact actually, the fact that sine of 30, meaning 30 degrees, is equal to half. What this means is that no matter what, well, 30 degrees is going to be my reference angle here. So I'm actually just going to draw an example. 30 degrees, well, I know from last time that sine is opposite over hypotenuse. Remember SOHCAHTOA? Sine is opposite over hypotenuse. So from 30 degrees, I could put opposite as 1 and hypotenuse as 2. I could do another triangle with a 30-degree angle, and this time I can maybe make it 10 and 20 because it's going to reduce. And I could do a bunch of other triangles. Point is, you cannot have a 30-degree angle in a right triangle and not have the opposite over hypotenuse reduced to 1/2. It's just impossible the way that sides and angles work out. And so what I want you to do, using this knowledge, can you tell me what x would be? Well, a lot of you are going to say, oh, well, x is 9. And how did we know that? I knew that because I know that sine of 30 has to be 1/2. It has to be, because that's what it reduces to. And so, 9 over 18, which gives us, here, let me erase that actually. And then x equal 9, since 9 over 18 reduces to 1/2. So using sine of 30 was really helpful there. I can give you another example here. Let's call that number 1. I could give you another example here. And let's say this time we have a 40 degrees and I have an 8. Actually, let's undo that. I have x and I have 12. Well, this time we don't quite know, we don't have like a nice 1/2 to go from. A lot of students are pretty good at picking out, well, that's adjacent and that's hypotenuse, so I know that I can use cosine of 40 degrees. But if you type in cosine of 40 degrees in your calculator, you get like 0.766, blah, 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 blah. It's an irrational number. It's a big decimal. So that's where the issue comes in. It's not as easy to pick out what that would be. But here's what I want you to know, is that every single angle has a specific value for each of the trig ratios. So for example, sine of 30 is always 1/2. Cosine of 30 is always 0.866. Cosine of 40 is always 0.766. That is a very specific tied value to it. And so because of this, well, here. We can use these to write equations to solve for missing sides. All right, so here's what I'm talking about. Let's go back to number 2. Cosine 40 is a very specific value. And cosine, I know, from SOHCAHTOA, is adjacent over hypotenuse. So we know that's x over 12. Well, because cosine of 40, that's a value. It's not cosine times 40. It's cosine of 40 degrees. That is 0.766. And so what I can do is I want to cancel out my denominator and get x by itself. So I can multiply both sides by 12, because that will cancel out my denominators. I get x equals 12 cosine of 40. And that I can just type into my calculator. 12 cosine 40. And I get 9.19. The little squiggly equal sign, that means approximate. That means I've rounded. So actually not too bad. Just some good times in your calculator. Okay, let's make this 15 degrees. Let's make this side 4.5 and this side x. Well, this time from the angle I've been given the opposite and adjacent, so I know that I can say tangent of 15 equals 4.5 over x. Well, this time x is in the denominator. So this time what I can do is, I don't like denominators, so I'm still going to times by x, which cancels out x to the denominator, so I get x tangent of 15 degrees equals 4.5, and like we said, tangent of 15 is a specific value, which means that what we can do is divide both sides by tangent of 15. So x is going to be 4.5 divided by tangent of 15. And so I can type that in my calculator, 4.5 divided by tan 15. I get 16.79. Okay, a lot of people have asked me, how much work am I required to show? Because, shocking, you're required to show your work. Who knew? The work that I need you to show is for something like number 2. I need you to show me how you're getting x. So if you can do this part, and I want you to show me this part, I'm okay with that. It'd be really awesome if you showed this as well, because then I know we're getting everything even more. That is what I'm looking for on your homework. So yes, you have to show your work. That's what I'm looking for on your test especially. Okay, well now, let's do another example. Let's say I give you this. I want to know if you could tell me what theta is. Here's what I know. I know sine of theta is 3/6, which reduces to 1/2. So sine of what angle gives you 1/2? Well, I'm hoping if you remember from this side, sine of 30 degrees reduces to 1/2. And so I can use that ratio to pick out the angle. The only problem comes, let's see, the problem comes when I'm given something that I don't know the ratio for. So let's say, let's go 7 and let's go 10. I don't know what ratio or what angle is going to give me a tangent of 7/10. I don't know that off the top of my head. Fun fact though, your calculator does, and it's using something called inverse trig. And what inverse trig does is it matches a ratio to its angle. And so how that looks is angle, instead of looking at tangent of my angle 7/10, I'm going to take inverse tangent, that's what that little -1 means, it's inverse, of 7 divided by 10. And where would you find this on your calculator? Well, if you look above the tangent button, you will see a little option for tan inverse. So you're just going to need to hit second and then tangent on the calculator. So I go ahead and type that in, and I got tan inverse of 7 divided by 10. Hit enter, and I get 34.99 degrees. How much work would you like me to show Miss Lambert? Literally, if you could just show me this step, and I'd be happy as a clam. Finding angles is nice because it doesn't take as much effort as finding sides. And even then, your calculator is doing most of the work, so that's convenient. Okay, the last thing that I want to go over, how much time? What time is it? That's what I'm looking for. Okay, great. The last thing I want to go over is just a word problem with you. So, let's see. A tree casts 5.6 meter long shadow. The angle of depression from the top of the tree is 42 degrees. How tall is the tree? All right, let's draw out what we know. We have a lovely tree. I'm gonna need more room than that. Take 2. Lovely tree, and it casts a shadow. Shadow. The shadow is 5.6 meters long. I want to know how tall the tree is. So I have a triangle created. But it's talking about this angle of depression from the top of the tree. Can't have shadow without the sun. All right, so let's go over some vocab. Angle of depression. Okay, here's what you need to know. An angle of depression just means that you're looking down. So from the top of the tree, I am, like, if there was a bird right here in the top of the tree, thank you, it's a blue jay, obviously. So if there was a bird, and the bird is looking at eye level, and then he looks down. This is my angle of depression. And so, with that being said, angle of depression usually comes with an upside down triangle, like so. And so I could label this part 5.6 and this part X, and this triangle has a 42 degree. Notice the black triangle is congruent to the upside down triangle. So I could also put my 42 degrees this way. Because of this, this is also the same as what we call the angle of elevation, which means we're looking up. So there's actually an angle of elevation right there. So it's from the ground to the top of the tree, because that's where you're looking up. So let's say there was like a worm, and then the worm lifts its head and looks up at the top of the tree. So that would be an angle of elevation because he looked up. The bird is an angle of depression. And you notice that the angles are the same. They are always located between the base of the triangle and the hypotenuse of the triangle. Always, always, always. Because as is illustrated here, the only difference between the two is which way am I drawing my triangle. Am I drawing my triangle upside down like the blue one to give me an angle of depression? Or am I drawing my triangle normal ways to give me an angle of elevation? Point is, they are the same thing. And so I'm going to go through and I'm going to solve this now, because I see I have an opposite and adjacent side. So I see that tangent of 42 degrees is x over 5.6, which means I can just times both sides by 5.6. So x equals 5.6, tangent of 42. And I get 5.04 meters. All right, if you have any questions, please shoot me an email. We could set up a video conference, or you can ask me after school.